Hi, everyone. In today's lesson, we're going to talk about probabilities with and or. Let's start with an example. So it says there is a spinner with 15 equal areas numbered 1 through 15. If the spinner is spun one time, what is the exact probability that the result is a multiple of 3 and a multiple of 2? So a couple of key words here. First things first, we're spinning the spinner one time, and we want to know the exact probability. And remember, exact probability means to express your answer as a fraction, that the result is a multiple of 3 and at the same time a multiple of 2. So still only spinning the spinner one time. So the way we're going to do this is we're going to call the multiple of 3 event A, and we're going to call the multiple of 2 event B. And we're going to create two sets of numbers. The set of numbers, so we'll call this set A. The set of numbers in set A are going to be all multiples of 3. And then the set of numbers in set B are going to be all multiples of 2. And then we're going to compare the two sets together. Remember, a set is just a fancy word of saying a set of numbers or a collection of numbers. So let's use blue to highlight all values that are multiples of 3. Multiples are what we count by, so we're counting by threes. So 3 would be the first one. We can use that. So we've got 3, 6, 9, 12, and 15. So all of those numbers there are multiples of 3. So let's list those in set A. So we've got 3, 6, 9, 12, and 15. And now let's talk about set B. Set B are all the numbers that are multiples of 2. So let's go ahead and count by twos. 2, 4, 6, 8, 10, 12, and 14. So let's list those down. So we've got 2, 4, 6, 8, 10, 12, and 14. So what I'm asking for you is to tell me where's the overlap, right? Where are the things in common? So do you notice that 6 has a blue highlight and a green highlight? And so does 12. 12 is also a green highlight and a blue highlight. So 6 and 12 are both numbers that are multiples of 3 and multiples of 2. So my answer is just 2 out of 15. There are two numbers, more specifically 6 and 12, that are in both sets, that are both multiples of 3 and multiples of 2. Now, if you want to write it properly, you can say the probability of event A and B. Remember this symbol. This symbol means and. I don't know if we've talked about that before, so I just want to make sure we cover it. So and. So A and B, right? All right, let's try another example. So similar, we have Mikey rolls a 12-sided die. What is the exact probability that he rolls an odd number and a multiple of 3? So odd number would be here, and then we've got multiple of 3 here. So we can call this, like we did before, event A and event B. So remember, we have a 12-sided die. If you want to write down all of the numbers you can, the sample space to choose from, the 12-sided die would just include numbers 1 to 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. You don't have to write this out. This is just for me to show you. So event A, we'll call this set A, is any odd number. So on this list, what are my odd numbers? Well, 1, 3, 5, 7, 9, and 11. We have to stop at 11 because 12 is the last number. And then event B says multiple of 3. So let's call this set B. So set B is any multiple of 3. So let's count by threes. 3, 6, 9, and 12. So if I want to find the probability of event A and event B, remember the symbol for and, I'm looking for what's in common or what's the intersection. So I clearly see a 3 in both. I see a 9 in both. So that means my probability of me rolling a number that is both a multiple of 3 and an odd number is just 2 out of the total of 12, which we can reduce to 1 out of 6. That would be my probability. So remember, if you want to highlight this or understand or underline it, probabilities with and mean It's the intersection of sets. Intersection is another way of saying what's in common. So what's in common would be our probabilities with and. All right, let's take a look at or now. So example number 3 says, same thing, we have a spinner. There is a spinner with 15 equal areas, 1 through 15. The spinner is spun 1 time. What is the exact probability that the result is a multiple of 3 or a multiple of 4? So same scenario goes. We still need to break up our two events. So multiple of 3 we can call event A, and multiple of 4 we can call event B. So let's break it up into set A and set B. So multiple of 3, we can highlight it if we'd like. Let's use blue for that. So all multiples of 3, 3, 6, 9, 12, and 15. Let's go ahead and label that here. So 3, 6, 9, 12, and 15. And then let's talk about event B, which is a multiple of 4. So a multiple of 4, we'll actually use a different color for that. Let's use yellow, and let's use and highlight that. So multiple of 4, count by 4s. We've got 4, 8, 12, and then 16 would be the next one, but it's not there. So let's go ahead and list that out. So 4, 8, and 12. So I want to know if I'm I'm spinning this spinner 1 time, I want to know the probability that I will get either a multiple of 3 or a multiple of 4. So what that means is I want the union of these two sets. And union just means all of the elements together. So let's count them out. How many elements do I have? I've got 1, 2, 3, 4, 5, 6, 7, 8. So unfortunately, 8 out of 15 is not the answer. And the reason why is because I have some overlap here. By counting these 1, 2, 3, 4, 5, 6, 7, 8, I've counted 12 twice. So I don't want to do that. So really my answer is 7 out of 15, because you don't want to add any multiples that you see more than once. So I know this might be a little hard to remember, so there's a formula. So if I want to do the probability of A or B, here's the symbol for or. The formula says it's the probability of event A happening plus the probability of event B minus the probability of A and B happening together. Remember, this is the symbol for and. So let's take a look at the probability of A. So the probability that I get a multiple of 3 is 1, 2, 3, 4, 5. There's 5 of them, so it would be 5 out of 15. Let's talk about the next one. Probability of event B, probability of getting a multiple of 4. 1, 2, 3. Well, there's 3 of them, so we would say 3 out of 15. And then we have to subtract the intersection, or what I'd like to call the overlap. So this A and B sometimes is referred to as the overlap, or what's in common. How many numbers are in common? Well, 112. So we would say 1 out of 15. So if we added these up, 5 plus 3 is 8. 8 minus 1 is 7. So that is how we prove it using the formula, 7 out of 15. So you want to get used to this formula. I know it's new, I know it might be a little confusing, but this formula for OR is something that we're going to use a lot in class in the next couple of weeks or so. So make sure you have this written down if you don't already have it. All right, let's take a look at example number 4. And I'd like to do example number 4 by just using the formula. So we have Mikey rolling a 12-sided die, and again, wanting the probability that he lands on an odd number or a multiple of 3. So event A will be an odd number, and a multiple of 3 will be event B. So I want the probability of A or B, which is the probability of event A plus the probability of event B minus the probability of A and B. So if you want to write down some things, this is the OR again. and this is and, the symbol for and, which is my overlap, anything that's in common. So odd number is what I want to do first, the probability of getting an odd number. Well, how many odd numbers do we have for a 12-sided die? We have 1, 3, 5, 7, 9, and 11. So that makes 1, 2, 3, 4, 5, 6. So we have 6 numbers out of 12 that are odd. Now we want to add that to the probability of event B. Event B is a multiple of 3. So how many of those do we have? 3, I'll use the same color, let's use green. So 3, 6, 9, and 12. So we've got 1, 2, 3, 4 numbers that are multiples of 3 out of 12. And we want to subtract off anything that we've added twice or any overlap. So it looks as though the only overlap we have is 3 and 9. So there are 2 numbers that are both an odd number and a multiple of 3. So we have to make sure we subtract that off. So we have to subtract 2 out of 12, those numbers. So if we add 6 and 4, we get 10. 10 minus 2, we get 8. So 8 out of 12 would be my final answer, which I believe you can reduce by dividing top and bottom by 4. So by doing that, you'll actually get 2 out of 3. So a couple things to know here. When dealing with probabilities with OR, it's called the union of 2 sets. And you want to make sure you remember this formula for OR. All right, that's it for today. If you guys have any questions, now's a good time to jot them down. Otherwise, we'll see you in class tomorrow. Have a good night.